Continuing on lesson 9.4, where we were on example number 3 in your notes, solving this triangle. We had already found B by using the law of cosines. Now I need to find angle A. Well, the good news here is I can use the law of sines to find angle A. So I'm going to do the sine of A, which is what I'm looking for, over the side A, which is 11. And this is a good review of the law of sines. So the sine of B, which is 34, over side B, which we now know is 7.9. We grab a calculator, and in our calculator we're going to go 11 times the sine of 34, find an answer, and then we're going to divide that by 7.9. That gives us a decimal. So we're looking for angle A, so we have to do the inverse sine of that decimal, and we get 51.1. Now it's really important that you do this with your calculator so that you can figure out if your calculator does a different order or something. So you should be able to get these answers. Now angle C, I already know angle A and angle B, so I just take 180 and I minus angle B, which is 34, and I minus angle A, which is 51.1, and I get 94.9. So I used the law of cosines, the law of sines, and the triangle theorem that says all angles are 180. Number 4, we are just looking for side A. And I know angle A, and I know side B and side C. So I'm going to use the law of cosines to help me find side A. So I go A squared equals 23 squared plus 26 squared minus 2 times 23 times 26 times the cosine of 114. And then I can just grab a calculator and put all of that in. That is so awesome to have graphing calculators that you can just do that all in one step. 23 squared plus 26, well, that was supposed to be squared. 26 squared minus 2 times 23 times 26 times the cosine of 114. You get 1691.5. Now we just need to take the square root of that to find the answer. So I take the square root of that answer and I get 41.1. That is what side A is. Now in your notes you have a table where you're supposed to identify the case and determine which process must be used first to solve the triangle. I would like you to turn off the video for a second and look at these and try to figure them out. Now a big hint is if you're stumped and you don't know which one to use, you're going to use either law of sines or law of cosines to get started, then draw a picture. That's what I do. Okay, turn it off. Now let's look at what you should have discovered here. So when you drew this picture, you notice that you have side and an angle and a side, and it's side angle side, so we would have to use the law of cosines. This one right here, we really don't have enough information, so really the first step would be to take 180 minus 12 minus 7 to find angle A first, but then you would have enough information to use the law of sines, because you would have 3 angles really in one side, so you could do a ratio of sines. The next one, you have an angle and 2 sides. The angle is in between the 2 sides, so it's side angle side, so you would have to use the law of cosines. Bottom left, you have an angle, and you also have side A, so you have enough to do a sine ratio, so use the law of sines. The next one, you have 2 angles and a side, which is enough information for you to do that ratio for law of sines. The last one, side, 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 the only way you can do that is with law of sines. All right, let's look at how this will happen in real life, because I told you this is really useful. I think law of sines is easier, but I really think law of cosines is so applicable. because you can think of so many examples of where you just know the three sides of the triangle. And this problem isn't in your notes, but I thought it was a really good one, so I want to just throw it in and you can just enjoy it. So an organism's step angle is a measure of walking efficiency. The closer the step angle is to 180, the more efficient the organism walked. You had no idea that we measured organisms and their efficiency to walk. The diagram shows a set of footprints for a dinosaur. Find the step angle B. So here you have, and this, by the way, this is, the right foot, left foot, right foot. So we're measuring their step angle here to see how efficient this particular dinosaur was. So what we're trying to find is angle B. So I'm going to use side B as my beginning point. So 316 equals 155 squared plus 197 squared minus 2 times 155 times 197 times the cosine of B. Wow, that's a lot of math going on there. So 155 minus 197 squared is 61,070. I take 37,022, which is 316 squared, and divide it by that. Now you might be concerned because we have a positive divided by negative, and we end up with a negative. But that's okay, because when we end up with cosine B over here, when we take the inverse of cosine B and cosine N is equal to this, then we get 127.3 degrees. So this dinosaur wasn't really too efficient in walking. It's not real close to 180 degrees. The area formula, and this is in your notes, so write this in your notes. And if you want, you can look this up and see how Heron derives this formula. But it's basically that we start out by looking at half of the perimeter of the triangle. So with the perimeter of the triangle is side A plus side B plus side C, and then you cut it in half or multiply by 1/2. The area is the square root of this semi-perimeter times the semi-perimeter minus A times the semi-perimeter minus B times the semi-perimeter minus C. And here is how it would be used. So the intersection of streets, let's say you have this piece of land that is locked by this triangle of streets. So 170 yards, 340 yards, 350 yards. How we solve it is the first thing we do is we find the semi-perimeter. So we go 170 plus 240 plus 350, and then we multiply by 1/2 or divide it by 2. We get 380. So then we use the formula 380 times 380 minus 170 times 380 minus 240 times 380 minus 350, and through the awesomeness of calculators, we end up with 18,367.4 square yards. Let's do the problem in your notes. So find the area of ABC, round your answer to the nearest tenth. First thing you're going to do is solve to find the semi-perimeter. 12 plus 10 plus 18 divided in half is 20. Now, if you think about this, you could have went 6 plus 5 plus 9 and gotten 20 also. Then we use the formula square root S, which was 20, times 8 times 10 times 2. So that's the 20 minus 12 is 8, 20 minus 10 is 10, and 20 minus 18 is 2. Use a calculator, and you find out that the area of this triangle is 56.6 units. And we are now done with the notes.